Good afternoon, and welcome to this beautiful room. First of all, it's a fantastic setting. We have a session this afternoon where we're going to look at waste and soil technologies, so focusing on destruction technologies. Number of presenters physically in the room and some online. There will be at least one presentation in Spanish, so if you need to have your earphones, you'll need to go and get them. Some words from you, John.
Good afternoon, dear colleagues, and together with Nico we'll chair this session. I hope that we will enjoy and get information on different technology for the treatment of POPs waste. So the first presentation is from Grégoire Hamon, I'm correct? So let's start.
Good afternoon, thank you very much for being here. Me di cuenta que se puede hablar en español, así que
I was told that I could speak in Spanish, so I will try. My name is Grégoire Hamon, and I represent the HCH group at an international level, and I am in charge of the exportation. Basically, we do work with POPs, HCHC, and pesticides. Thank you. So how could this group be described? It's a family enterprise that it's in charge of proposing solutions to manage the environment. We are a subsidiary of the HCH group that works with hazardous waste. I'm going to give you some key figures. For starters, we have 5,000 employees, and our turnaround is higher than 700 million euros, and we work especially with industrial waste. Also, we are present in 15 countries across the world. Now on the screen, you can see in blue, dark blue, our subsidiaries where we are present. For example, we're in Chile, in Peru, in other places in Latin America, also in South Africa. Also, we have branches in Europe. And if you look at the map, you will see that we have some points in orange. And what is this? In these points, these are the points from which we export hazardous pesticides to France to incinerate them. That's what we do. How do we do these? That's a very interesting question indeed. The group offers solutions at an international level. I'm going to give you some simple examples so you can understand our processes. It's quite easy indeed. What we do is go to a country, any country in the world, that's it, and we collect the pesticides and we identify them. It's very important as a first step. We need to identify, characterize the pesticides. And then what we do is an analysis of the waste on site. That's what we do. At the same time, we need to do some bureaucracies with several bodies in order to be able to transport and to transfer the hazardous waste, which is sometimes can get a little bit of time because we need some months waiting for some permits in order to cross borders from one country to another. And then we export these pesticides to France once we have these permits using different channels, different waste channels. Because there are different ways of putting the waste on different waste channels. I will talk about that later. We also collaborate with local government, with very important industries, and also we work with supranational organizations. On the street, you can see some examples of countries we work in. Thank you. Sorry, I was feeling a little bit uncomfortable, but now I feel much more better. I like to just go around. I don't like to be just next to the screen. So now you can see the countries in which we work or we have worked: Bangladesh, Macedonia, Ukraine, Bulgaria, Egypt, Turkey, Belize, Belarus. We have several pesticides and HCH projects there. Well, I'm a little bit shy. Well, I don't know. Something happened with the slide and I forgot something really important. Were already collaborating with the government of Aragon, and I forgot about that. Sorry about that. We have been collaborating with Ibertrade in Spain. We have Javier Domínguez there, who is the responsible of the subsidiary. We started working in 2021, 2022. We started collaborating with the government of Aragon, and we work with more than 100 tons of solid waste. Sometimes we found some obsolete pesticides, and we need to carry out a very specific process because, as I said, the identification, characterization of the waste is very important. We perform some tests in situ and also using a special X-ray machine to be able to identify the chemical compounds of the waste. Sometimes we work in Eastern Europe where some obsolete pesticides can be found, working in bunkers where working is not that easy, but we do have the equipment in order to be able to analyze and identify the waste before exporting them to France. As I said, identification and characterization is essential. Another mistake that I'm seeing is, sorry, because there is a mistake about the classification in this slide, so I apologize about that. So as I said, Tredi is a 100% subsidiary which works with the management of hazardous pesticides internationally, and we have elimination plants and treatment plants. We have 2 plants actually in the area of Lyon in France. And also we have several treatment channels. We have a capacity of 350 kilotons of capacity every year. And we have different ISOs as well, as you can see on the screen. Please, now on the screen you can see different 2 pictures of our treatment plants. On the left we can see Tredi Celeste, one of the biggest in Europe with big capacity, and then we have Tredi San Vulbas. It's a little bit old, but it's specialized in the treatment of HCH and other POPs. Let's talk a little bit about Tredi Celeste. It has 4 rotative kilns with around the capacity of 294,000 tons a year. And it's important to know that energy is produced through the disposal of the waste, the pesticide waste. This is something essential, it's something new, and we do it in Tredi Celeste. I think you will have to help me with the names about the chemicals. I think it's, and we work with different chemicals, with sulfur, chlorine, and bromine, and we also work with different wastes in different stages: solid, powdered, those who are toxic. And so Celeste is divided in 4 main blocks with, for example, several rotary kilns. And for example, in Celeste 1, we work with low halogenated hazardous industrial waste and with low halogenated waste. And then in Celeste 2, we treat specifically more complex waste. Then we have Celeste 3, and there is where we treat contaminated packages. And then we have Celeste 4 when we manage and recondition waste. I'm going to show you a graph now of our treatment plant. You can see the rotative kiln in the middle. And you can see also the different channels that go to this kiln for matters in different states, for solid waste, gaseous waste, and also depending on the calorific level. Also, solid waste go directly into the kiln, and on the right you have the emissions and how we treat them, vapor treatment, gas treatment. Let's talk now a little bit about the other plant, Tradisem Volvas. It has a capacity of treating every year 50,000 tons. And here we can treat materials with a very high percentages of chlorine, sulfur, and bromine, which is very, very important. We also regenerate bromine through its treatment. And these, as I said, the plant of Tredi is quite old, but it's quite known because we work with more specific materials such as pesticides and HCH. Let me show you an image of these. We can also see the different channels to manage the different kinds of waste and sending them to the kiln. And on the right, the way we treat emissions, so we reach neutrality when it comes to emissions. I think this would be all. I hope you understood everything. I know I have a particular accent in Spanish. I don't know if we need to go on or if someone can ask a question. We can do a little bit of a Q&A. I wanted to know which would be the biggest disadvantage of this kind of treatment. Maybe it would be the long distance transport. Is there any kind of disadvantage to this? Well, I think right now we have a lot of geopolitical problems and there's a lot of difficulties around international transports. Rates are higher now. And it's very, very important to manage HCH pesticide and pesticides globally, not only in France. We need to do this all around the world. Because at the end of the day, we need to find solutions to fight against these at an international level. So we need to deal with geopolitics as well, and we need to find alternatives, and that's what we do at Tredi.
Okay, thank you. Thanks again, Grégoire. Which means the next presentation will be from Søren Eriksen, who's going to talk to us about low temperature thermal desorption. I'm sure Søren will be able to explain that much better than me, so I'll move quickly to Søren and he can explain.
Okay, good afternoon. I'm Søren Eriksen with Kryer Veolia in Denmark. The topic of today is the can we make the thermal remediation double as a destruction technology and really make it compete with or be a sustainable alternative to traditional high temperature incineration? Thermal remediation is a source zone technology. We apply heat to volatilize organic chemicals, extract them along with the water vapors generated, capture it in vacuum, bring it to the surface, and treat it there either by destruction in a thermal oxidizer or condensation and adsorption on typically activated carbon. So traditional thermal remediation is really a separation process, get the contaminants out of the soil and treat them separately. What we do is, there are different ways of heating soil, but if we want to address some of the persistent chemicals, we need to go to temperatures higher than the boiling point of water, and then it's only the thermal conductive heating that will work. So we install electrical heaters in the soil along with some temperature probes, and then we start heating, and the temperature will gradually increase to the boiling point of water, where we are able to extract volatiles, BTX, chlorinated solvents, pretty much any organics with a vapor, with a boiling point up to about 180 to 200 degrees. Anything less volatile will have to be evaporated or destroyed at higher temperature, meaning that we have to exclude the groundwater that will allow us to heat even further, dry out the soil and reach higher temperatures. Typically the target will be 300 to 350, where most organic compounds give up and leave the soil. It can be used for aromatics, pesticides, PCBs, dioxins, PFAS. So the traditional thermal remediation is really all about heat it up, get the contaminants out, and that can be done for a range of contaminants, dioxins, PCBs, PFAS, mercury. But the question is this getting it out? Is that really what we want? What about highly toxic compounds? What about something that is solid at the treatment plant temperatures and tend to block all the pipe work? What about something highly reactive? Is there any benefits of leaving the contaminant vapors a bit longer in the heated soil and try to achieve some kind of destruction or mineralization? I've brought a few examples. One is a mixed site in Denmark with pesticides and mercury that was treated in a pilot scale or tested in a pilot scale. There's a full-scale dioxin remediation from Vietnam, and finally some work we've done on a lab scale with PFAS. So the mixed contamination with pesticides and mercury, the mercury and parathion, it's an organophosphate, highly toxic, they're the main reason for doing the remediation, but there's also a large amount of elemental sulfur, which is not really a concern in terms of environment, but that prevents the evaporation of mercury, which is found primarily as mercury sulfide in the first place. So what we want to do is really to set up wanted to do was really to set up a pilot test that allowed to do the chemical conversion of mercury sulfide required to free it as elemental mercury that can be evaporated. We also wanted to make a controlled decomposition of the parathion to prevent having excessive levels of flammable gases, and also possibly to prevent having to deal with all the parathion in the treatment plant. Finally, we wanted to oxidize the sulfur to treat it as acidic gases that could be neutralized rather than battling all the solids. The results were quite encouraging. We managed to reduce the vast majority of the parathion, making the health and safety much more manageable, having 10 grams of parathion from the 25 cubic meters of soil extracted rather than the 50 kilograms originally present. At about 200 degrees, all the organics were remediated from the soil, whereas the mercury proved to be a bit more stubborn than anticipated. from lab testing and required 500 degrees to get below the 3 milligram per kilo target. It also turned out that it was manageable to keep the amount of flammable gases at a controlled level and stay well clear of anything that could be ignited, which is obviously very important if we want to continue this on a full scale. We want to remediate it, not set it on fire. The dioxin remediation was a full scale. It originates from Agent Orange spills in an airport in Vietnam. The dioxins are accompanied by some of the phenoxyherbicides that it was originally a side product in. The approach was to do it in a pile, so excavate and collect all the dioxin contaminated material in the area, pile it up and treat it on the surface but still on the site. The target temperature was 335 degrees, found by lab studies, and it required a 3-week residence time at temperature. There were 2 phases, each of them 45,000 cubic meters. Results in terms of dioxins were good. The end results were well below the target of 150 ppt. The 2 phases came out a bit differently. Phase 2, learning some of the lessons from phase 1, so achieving a faster heating rate and also achieving higher temperature and reaching somewhat lower dioxin concentrations. A bit of an unexpected side effect, however, was that there was a large degree of dioxin destruction in the piles, and the slower heating first phase was actually achieving more destruction than the faster and apparently from the end result better second stage. That's a bit of something to think about, that by heating a bit slower, there's more time to achieve destruction. We've done a little work on PFAS in the lab. The approach was initially the traditional one, heated and extracted, and that works. You can get below 1 microgram per kilo, takes 400 degrees for a couple of weeks. We also noticed that we got some of the PFAS compounds out, whereas others were destroyed. We were able to identify some of the decomposition products, some perfluorinated alkanes by online mass spectrometry, which is something that could be a challenge on a full scale because there's no commercial analysis methods really available for this class of compounds. So we would convert the PFAS into something that we couldn't easily analyze. So we went on for a second round, realizing that PFAS was really the most difficult to remove compound, and just spiking that to sand, and then go to see, now that we were doing degradation already, could that be carried further onto achieving some kind of mineralization? So heating slow, minimal ventilation rate, try to keep the vapors at high temperature as long as we could. Cheating a bit, adding a decomposition reactor where we tested a couple of different catalysts to see what we could do. And it turned out that, as expected, the PFAS is largely removed from the soil, but only a small fraction actually survived. And we had 25% of the fluorine originally present in the PFAS as water-soluble fluorine, which is clearly mineralized. And the 75% turned out to be insoluble, and some XPS analysis indicated that it's a fluorine mineral, but it's still something we need to look a bit closer into proving that that is actually the case. We were able to close the mass balance, meaning that we don't have a large fraction of the fluorine escaping as something else. However, you would still like to be able to analyze for these known degradation products, but it's reassuring to know that we can account for the fluorine that we had in the test. The conclusions of these 3 examples is really that you can balance the evaporation and degradation and try to see whether you want to take the compounds out as they are, or if you want to try and degrade them or convert them chemically by controlling heating rate and ventilation rate and the temperatures you apply. This can improve the health and safety a lot if you can convert the most toxic compounds to something a bit more unpleasant or a little bit less unpleasant. Some of the contaminants, they really require chemical conversion to be able to extract them at all. And then, of course, if we can achieve mineralization, you can reduce your waste and activated carbon management challenges. And it's not necessarily better to extract fast. So what are the consequences of this line of thinking? Can we make these degradations in a way that it can replace sending the soil off for high temperature incineration, which is not really energy efficient since soil doesn't burn? I'd like to raise a few words of caution. When you start doing chemistry, make sure this is really what you want. Look out for degradation products and make sure that you are not producing any byproducts that are more unpleasant than what you started out with. Thank you. And any questions or comments that are not raised here, please find us. We'll be here for the next few days.
Thanks, Søren. It's very interesting.
Thank you very much. Stephen Robinson with FAO, managing a project in Central Asia, and contaminated soil is obviously a big issue there. Two questions. Maybe I missed it. You evaporate the organics. I missed the part what you do afterwards with them. Question one. Question two. Did you ever do an estimate of how many dollars or euros per cubic meter your technology costs? So if I come to a football field 10 meter deep, so that I can make a ballpark number, what is the budget needed with your approach? Thank you.
The point of when the contaminants are extracted from the soil, they either have to be destroyed in a thermal oxidizer or they'll have to be captured on a sorbent for later destruction. Typically it will be activated carbon. So the treatment train will be condensation, conditioning of air by cooling and drying, and then filtering of air and filtering of condensate. In terms of cost, we will be quite happy to look at any inquiries you have and give you a more targeted answer, because there's quite some economics of scale in this procedure.
My name is Egmont Ottoman. I find your presentation very interesting, particularly from two aspects. The first one is electricity consumption. It would be interesting to note what kind of connection you would need, because I don't think you can do this as 220 volts.
The big example I showed with the pile from Vietnam was connected with 8 megawatt of heating power, and that allowed heating the soil in about 6 to 8 months.
Okay.
So there's some balance you can do between how fast do you want to heat and how much power do you have available.
Thank you. The second question related to the material science of how you actually isolate the material and what materials, obviously it's secret, but the interesting thing would be what material lasts or survives 500 degrees C and still covers the soil.
The traditional piles are built from concrete blocks, and then with some outside sealing of polymer liners on the cold side, so to say. We also have some insulated materials with some higher temperature silicon-based materials and so on. They don't last all the way to 500 degrees, but by building it up in a controlled way and maintaining an inward gradient, it's still possible to isolate the contaminated soil from the surroundings.
Interesting, thank you.
And then the next we have is a video presentation which we're going to show. from Peng, and it's about the progress of environmentally sound management and disposal of pesticide POPs waste in China.
So the pesticide waste is like these pictures indicated, and in the former storage places, we can find lots of the POPs pesticide stockpile abandoned, and also in formats mixed with the other waste. And in previous pesticide manufacturing places, we still can find some production waste in formats like the wastewater and the sludge, slag. And we can see there are still some of the waste, just like this, the contaminated soil. The next, we come to the system of the environmental sound management and disposal. We need to formulate some legal documents and establishing the standards, carry out the source reduction, and establishing the eventualization. Then go through the packaging, handling, transportation, final disposal. According to the Basel Convention and the Stockholm Convention, the requirements for the waste, POPs waste. In China, we have formulated the National Implementation Plan, also set a specific goal for this pesticide waste. So in terms of the first group of the POPs pesticide substance, we have obtained, reached our goal for completed the disposal of identified POPs pesticide waste. So the major environmental sound management systems, that is, we have already established these systems of the hazardous waste management. And within these systems, we take care of the POPs pesticide waste. So how do we carry out the identification? That is two instruments. One is the national catalog of hazardous waste. The other one is the identification standards for the hazardous waste. So the other two disposal standards that is very important have determined the pollutant limit for the hazardous waste incineration. The other one, that is the standards for pollution control on co-processing of solid waste in King. Let's compare with the content limit of the POPs pesticide waste of the hazardous waste in China. The legacy POPs, the limit of the hazardous waste in China is the same limit value as the low POPs contents required by the Basel Convention, and but we do not keep the same value as the no POPs content, just like the chlordecan and alpha HCH and beta HCH and linger, and also androsulfan. According to this requirement, we have since beginning of the 2010 we carry out the identification for the pesticide, POPs waste, and the contaminated site in China, which is also based on the projects funded by the JEF and the UNIDO. So the other very important is the environmental sound disposal technology, which is major consists of the high temperature incineration that is follow very strict the pollutants emission standards, as mentioned in the early slides. The other one is the Semenking co-processing, and you can see that the characteristics of both these disposal technologies in China, and their geographic distribution of this disposal capacity and the disposal costs, and that was since the 2010 until the 2018 we carry out many these pesticide waste collection and transportation, and finally the disposal. These pictures indicated most of the on-site and digging and the training and packaging excavation. And in China, we have completed or identified the POPs pesticide waste disposal. The major disposal technology that is the co-processing by Semenking. The other one is the high temperature incineration. Then, and there are still part of them carried out by the safety landfill. And for the pesticide POPs contaminated soil, which was also carried out by the thermal desorption, let's come to the conclusion that technological trials and lessons learned and research supported by the project contributed to the 30 plans, regulations, standards, and guidelines have been integrated by the public administration agencies operating at the national and provincial and city-county level. The firms need to ensure the key staff is sufficiently trained on the hazardous waste management. Thank you for your attention. If you have any further questions you need to discuss, please email me by this email address. I'm sorry for another meeting, so I cannot discuss with you online. Once again, thank you for your attention.
So if I could welcome Montse Papiol. Montse is going to talk about the use of high temperature incineration as a destruction technology for POPs.
Good afternoon, everyone, and thank you for being here. And I will talk about the incineration of hazardous waste, and I will explain why I think it's positive when it comes to the elimination of POPs and to improve the environment. First of all, we are living in a context of economic change, climate change, and it's important to take all of this in account, and also to take in account the Green Deal and to work with it in order to preserve the environment. How can we link POPs and the Green Deal? I'm not going to enter into detail, but I would like to explain the final objective of the Green Deal. It aims to change economy to achieve a green future. And it has several action plans. I don't know if you can see it on the screen. And circular economy. Oh, excuse me. So the camera is not going to focus on the screen, right? No, don't worry. Yeah. So one of the main measures of the Green Deal is to achieve circular economy. We're going to be leaving behind these one-use concepts, and we need to try to use as much as possible the resources we have, because we know they're not infinite. And it's true that everything can be reused, but the Green Deal contemplates another perspective. It also aims to reach zero contamination. And in this case, and linked to the POPs, incineration is very important. And here is why it's so important to create this new economy without releasing more pollutants, contamination to the air. So here I'm going to show you an incinerator. This is a specific incinerator, different to the one of 3D, but mainly they are the same. I will talk a little bit about the different channels of management later, but right now I would like to say that the waste that goes into the kiln, and once they're there, they reach 1,100 degrees, both in the kiln and the combustion chamber, and there is where the waste can be destructed thanks to the high temperatures. And then we do have a chamber of heat recuperation, which can reach at 350 degrees Celsius. And then all this heat reaches a turbine of 5,000 megawatts. So the heat can be used, and can be used, for example, by houses, generating around 2.5 gigawatts of electricity. We also have the electrofilter, the catalyzer, and well, I just wanted to go about that briefly. I will then send the slides so you can look at them more with more time. And now I'd like to talk a little bit how we manage, how we assure the destruction of the pollutants. Mainly, we use temperature. We reach 1,100 degrees Celsius, so we can achieve the reaction of oxygen with organic matter, and it helps us to destroy molecules such as the POPs molecules. We also use turbulence. We have a rotary kiln, and we use that, and also the burners, because we need the greatest contact we have between the oxygen and the waste. And with these, keeping the waste in the kiln around 20 minutes, for around 20 minutes. We manage these, the total destruction of the POPs molecules and also the destruction of the organic matter. The waste in our incinerator, but in general, in several incinerators can be treated in different ways. The waste could be packaged or not, could be coming in crushed already, or we can crush it as well. We will use different ways depending on the state of the waste. For example, we can put directly on the kiln waste that can be solid at room temperature, but that reaches another state in other temperature. That's not a problem for us. We work with a staff that has great knowledge about waste treatment. We analyze constantly all the parameters because we want to make sure the combustion is proper. We also are in charge of managing the risks of the waste. We have a lot of security measures, and in summary, we also do manage the risk, all those risks around the waste. We also work with volatile metals such as mercury or arsenic, and we also work with sulfur or halogen materials. We have well-equipped labs, and around 10% of our workers work in labs at an European level. Thanks to these, we know what kinds of waste we're going to be dealing with because we analyzed them before. And apart from doing all of these, we do retrieve heat and we do retrieve energy from all the waste that we treat. For the grass scrubbing, we have different ways of doing it. We have 4 electrical fields where the combustion gas goes through, and the gas gets stuck to the walls thanks to these electrical fields. So we can also catch the ashes that also have a content in heavy metals. And as I said, we have 4 electrical fields to guarantee the sufficiency and efficiency of our equipment. These allows us to destroy different kinds of chemicals. And lastly, we have the scrubber and the quench. It's a kind of wet treatment. Quench is the first phase, and the scrubber has 3 another phases. In the first one, we have an acidic pH. It allows us to retain sulfur, chlorine, heavy metals, and the other phases also have an acidic pH, and it helps us to filter any chlorine that could be left from the first phase. And in these last phases, we also capture the sulfur oxides and any heavy metals that could be left, so we can assure the efficiency. And sorry, why are we special at Sarpi Constanti, our incinerator? one of our most important things is the way we introduce the waste to our kiln. We can get crush drums, crush bigs, big bags, and we have a shredder that allows us to crush or burn waste without our staff having to physically manipulate those wastes. We also have the same with pesticides. Sarpi Constantí, it's located in Spain, in Catalonia, and it's part of Sarpi Spain that has these centers that you can see on the screen. And all of them work with hazardous wastes. Conclusion. The best available technologies of hazardous waste incineration avoid the reintroduction of pollutants into the circular economy, reducing the effect to the environment and human health. And so we will be able to achieve the Green Deal and also the circular economy. That's so important to guarantee the health of people and also the health of the environment. Thank you very much.
Thank you, Montse.
My name is Ed Vahame, Alternate Resource Partners. Thank you very much for your interesting presentation. I have a question. What is your efficiency of the energy you put in by the waste and the electricity and the heat you supply to the to your community?
We burn the waste at 1,100 degrees, and when the flue gas arrives to the boiler, we achieve energy from 40 bars, 350 degrees, okay? And we produce more or less 3 megawatts per hour, between 2.5 and 3. We use for 95% of this steam is used to produce electricity, and 5% we use for clean the line. Okay.
Yeah, but I understand that. But
yeah.
My question is, the energy of your waste is transformed into heat, and what is your percentage of the energy which was in the waste arriving in the heat? If you have a normal electricity power plant, it's about 45%. What is how much of your kilowatt or your kilojoule you put into the kiln is ending up as heat?
Yeah.
That was my question.
I cannot say this percentage. I don't know it, but
that's no problem.
I can tell you.
Yeah, let's talk about that later on.
Yeah, okay.
Thank you.
So I'd like to introduce Saso Martinov, who's going to talk to us about an extremely interesting project for the disposal of DDT in Bangladesh.
So in the next 10 minutes, I will explain the pesticides risk reduction project in Bangladesh, which is a different presentation than the previous one. So the presentation, it will be about what is happening on the country level before the DDT reach, for example, Tredi for the final destruction. Okay. So it's a JEF-funded project, started in 2019. It's by December this year with the possibility for extension 1 more year. We work closely with the 4 different departments in Bangladesh, which means with the 4 different ministries. We have 4 components. The component 1, it's about the DDT destruction. Also about the management option on the empty pesticides containers. The component 2, it's about to strengthen the regulations and enforcement of the government of Bangladesh authorities about the pesticides registration, import, production, and sale. Component 3, it's about the usage of the pesticide alternatives to strengthen the laboratory capacities, also to provide alternatives for pesticides for the dry fish production, but also for the agricultural production. And component 4 is about awareness and communication. So the DDT disposal process in Bangladesh, it's a complex and highly technical, and in our case shows highlighted the lack of infrastructure, policy, and also institutional capacity of the government to manage with the waste. So we work closely with the 4 different ministries. So it was an interministerial operation. We work with the 6 different departments from different organizations, with the 2 export companies and government authorities, and also with the 6 Chattogram city where the DDT was stored in a medical sub-depot with 6 city government authorities. So communication in Bangladesh does not mean email. So if you want to communicate with the government, you must send official letter, print it, sign it, stamp, send the courier to the department. So in the whole process of the DDT disposal, we send more than 20 different letters. So this is the story about the DDT waste in Bangladesh. We started with the Department of Environment as our main counterpart. So the Department of Environment, they sent a letter to the Ministry of Environment, Forest and Climate Change about the DDT disposal operation. The Ministry of Environment sent a letter to the Ministry of Commerce about the DDT disposal. The Ministry of Commerce sent another letter to the Chief Controller of Import and Exports. Also, the Ministry of Environment sent additional letter to the National Board of Revenue, and additional letter from the Department of Environment to the Ministry of Environment. So our final goal is to reach the dangerous cargo inspection office. In March, Ministry of Environment sent a letter to the Ministry of Defense. Yes, we work with the Ministry of Defense for the DDT disposal in Bangladesh. So we're hoping that the Ministry of Defense will send a letter to the cargo inspection office, and our DDT disposal will start. Unfortunately, it didn't happen. So we get the first export permit with a 3 months duration. Then nothing's happened. We extend the export license for additional 3 months. Again, nothing's happened. Unfortunately, in Chattogram port, it's happened an explosion of the chemicals, where about 50 people lost their lives and about hundreds get injured. And they say no more chemicals in Chattogram port. So we sent so many documents to prove that DDT, it's not flammable, it's not explosive, it's only a chemical, it's only a poison. So it took them again a month or 2 to understand that DDT is not explosive. So we extend the 3rd export license, and then finally, we as a project send official email and letter to the Ministry of Shipping. Also, we send official letter to the Bangladesh Shipping Corporation about the DDT. The Ministry of Shipping sent additional letter to the Bangladesh Shipping Corporation. And then FAO initiated interministerial meeting with the Ministry of Environment. The Ministry of Environment called for the meeting where the Ministry of Environment, FAO, Department of Shipping, Bangladesh Shipping Corporation, Department of Agriculture, of Environment, and Polak had a meeting to talk about the DDT disposal. So the Ministry of Environment sent additional letter to the Ministry of Shipping about the DDT disposal. Then the Ministry of Shipping sent additional letter to the Chattogram port authorities. So we started in January, we're in September, but still nothing happened on the field. Then Department of Shipping sent an additional letter to the Bangladesh Container Shipping Association about the DDT disposal. And finally, the Ministry of Defense sent a letter to the Navy headquarters, and the Navy headquarters sent a letter to the Dangerous Cargo Inspection Office saying, okay, DDT can go out of Bangladesh. So we're not importing, we try to get rid of DDT of Bangladesh, and this is how it looks like. I'm sure the other countries are facing similar problem, but trust me, no one is facing this kind of problem like we face in Bangladesh. So finally, fourth export license, we get it for 3 months duration. And the shipment of DDT waste could start. So immediately after we got the permit, the Polyeco team, they start to work. So from October message, we start with the first shipment with the 6 containers and 133 tons. The second shipment, it's 11 containers and 244 tons. And the last shipment with the second containers on December 10 with less than 150 tons. The DDT was disposed on the medical sub depot in the middle of the city. Like, can you imagine now the DDT is here and should be transported out of Zaragoza. So the DDT was escorted by the police from the medical sub depot to the port. And of course, following the Basel Convention, 14 different countries, 14 different letters of notification should send from the Department of Environment and the Basel focal point to the countries to notify them about the DDT. What is important? To keep people informed. So we pay a lot of attention about the media achievements. So we have a 70+ media coverage. We reach about 460 people reach the FAO. Social media, we are developing a documentary about the DDT disposal from the phase 1 to the last phase that FAO can use as a training material for the other countries who wants to do the same. Also, we disseminate about 40,000 flyers and also reach farmers, about less than 500,000 farmers with SMS campaign. The Daily Star, one of the most kind of important news in Bangladesh, they have 1.1 million views about the DDT disposal. And also BBC Bangladesh also made an interview about the whole process. So, January this year, the minister itself, Mr. Shahabuddin, the Minister of Environment, Forest and Climate Change, declared Bangladesh as a free DDT country. Moving forward, the government is still facing a problem with the strategy about the hazardous waste management. Actually, they don't have a strategy. So we try to support them to develop a strategy of the waste management. Also, we are providing alternatives for the hazardous pesticides, better monitoring of the food safety of the pesticides residues in the food, and also the activities that at the moment are ongoing is to provide recycling options for the empty containers. And we'll try to work with the government to verify the Rotterdam Convention. Also, I would like to mention that the human poisoning pesticides from the pesticides in Bangladesh, it's present. Recently, the Minister of Environment informed us that the farmers are still using the plastic bags from the pesticide to store food. So using that food, they get poisoned, or unfortunately, we have dead cases. The Minister of Agriculture would try to reach the farmers and also will pay attention in our kind of second phase of the project. It's to reach the farmers. 25% of the total Bangladesh population is illiterate, which means they cannot read. Of those 25%, 95% are farmers, which means they cannot read the safety instructions on behind of the bag. What does it mean? So we're going to reach them with video or any kind of approach so they can understand to stop using the pesticides, containers or bags. To tell you about the Bangladesh is 3 times smaller than Spain and has 150 million people. So it's 3 times less than Spain by size, but 3 times more than Spain with the population. Spain is about 98 people per square meter. Bangladesh is 1,260. So, as I said, we'll pay a lot of attention on the communication. We'll develop a new SMS campaign, training videos, the DDT disposal workshops. Also, we will include the youth and the women because they're more open for new ideas, innovations, they will easily understand how to manage with the pesticides and also with the waste and the pesticides containers. This is the team who managed the DDT disposal in Bangladesh. And this is how it looks like. As I said, it's in the middle of the city. People lived nearby and they have offices inside. There is a people who work in inside building for more than 25 years. So can you imagine my office is here and DDT is in that door. So they work for 25 years on that way. And this is how the Polak did the job. Now everything is clean and it's transported to France. We have information that the trade already started with the disposal operation. So we hope everything will be done in next maybe month or two. So this is what is going on the government level before the DDT reach for the final destruction. Thank you.
Saso, many thanks. Javidan and me were obviously comparing how things look like in Azerbaijan. There are some déjà vus, but I think you have more problems with your project. I mean, chapeau for doing that. You mentioned the important point of empty pesticides container management. I don't know whether you have already all the solutions in place. If not, we have a very good consultant from Russia. He has been building up over the last 7 years the Russian collection system, so he's really sort of a shovel in the hand person. We are using him a lot, but I could put you in contact and maybe he would know some good colleagues in the Asia region who could help you with empty pesticides container management.
Thanks, Steffen. Definitely. It's activity that's ongoing at the moment, and it's a huge problem in Bangladesh because the industry, they don't pay that much attention what is going on with the containers. They just sell the product and that's it. And I forget to mention my close friends, Mark, who really helped us with the DDT disposal. So Mark, thank you for your expertise. Really, we really appreciate it. And you're patient to be in Bangladesh.
Thank you very much for your presentation. So we know that in Bangladesh it's pretty hard to manage hazardous waste. It's quite long and a very tough project. And I would like to know, just a simple question, what is the percentage of DDT waste that is produced in the country that is currently well managed or exported to Europe for final disposal? 100%?
So, yes, before we start the process, we ask the government to check is there any other obsolete pesticides in the country? They say no, it's only one place. So this is why I said the minister declared Bangladesh DDT-free country in January this year.
Thank you so much.
Yes, I have a question on the empty packaging one more time. I'm a little bit surprised that the companies the manufacturers are not interested to collect the empty packaging, because my personal experience is in Vietnam and in the Philippines, and there they have set up together with cement kilns a very good collection system on the empty packaging, where they then the empty packaging will not be reused again, but will be used for the energy content in the plastics. And so I was wondering, are those importers you're talking to, or are they the original manufacturers of the pesticides?
We initiate discussion with the Bangladesh Association of the pesticides. So we have a meeting with the Syngenta, with Bayer, with Barbarasa. We start to talk with them recently because on the phase one, the project was focused most on the DDT disposal. Now we focus on the pesticides, on the plastic containers. So we involve them and we're going to develop a memorandum of understanding of kind of a long-term cooperation, and they will take over when the project is finished. So it's ongoing now, but definitely they're on the board. Yeah.
That's what was part of the success in the Philippines and Vietnam.
Yeah. Mark, did I forget something? Or?
Saso, excuse me, once again a question. You cleaned up now the concentrated stuff. If I look at your photos, obviously there's now residual contamination. How important for Bangladesh is the question of contaminated soil? And as you said, developing a strategy how to deal with contaminated soil so that you can reuse them for agriculture or other purposes.
Fortunately, the medical sub-depot where the 500 tons of DDT was stored was flooded, which means now DDT is everywhere around, in the soil, in the water. We at the moment did a higher University of Bangladesh to do a soil and water analysis. We're expecting results to be ready by maybe end of February, beginning of March. Based on the results, we'll also kind of develop a program, potential program about that, but we need first to talk with the government about that. So Bangladesh has a lot because the DDT was in one place. I'm guessing pictures that are behind us in other countries, they're in multiple places and in more contaminated land and water. In Bangladesh, it's good that it was in one place, but it's bad because it was in the middle of the city. And Chattogram has 3.2 million people.
Next speaker is from the Republic of Moldova, Larisa Cupcea, and it's my pleasure to introduce my colleague with whom we worked since 2005, and we have managed to implement several projects. Larisa, one second. Larisa will try to summarize all of our activities which have been undertaken since 2005 till 2018, and in the last years she was actively involved in projects, in management of several projects in Transnistria, more or less in the same manner as our colleagues from FAO did in Bangladesh. So, Larisa, you have a floor, please.
Okay, hello everyone. I'm here not just to present what I'm working for many years, but I did this with my colleagues, Valentin, Ion, and Elena in some cases also joined us in some of the activities. I'm glad to work with them since early 2000s, and it's a lot of job. Oh, it's not working? Okay. A lot of job have been done so far. I'll start with the origin of the problem in our country. Moldova being as a very small country, we neither produce pesticide, but as an agricultural country, we use it a lot. Mostly since 1950s, we used more than 560,000 of pesticides, among them 22,000 of tons of organochlorine pesticides. Because of this and because of the lack of a very good strategy and management of such chemicals, we had a lot of pesticides spread all around the country. And we had, at the beginning, the quantities, estimated quantity was 1,700 tons, spread all around the country. Later on, after a small inventory, it was identified that the quantity increased. Because of improper storage condition in the warehouses, the pesticides were mixed with fertilizers, and that's why we cannot at that time identify the exact quantity of POP pesticides. And as usual, the biggest problem was the lack of resources to solve the problem, and we needed a lot of time to identify the funds needed, which were important for destroying or dispose of the pesticide, collect them and destroy them. The first action done in this field, we start with signing the Stockholm Convention in 2001, and later on, based on the decision taken by the government of Moldova, the action plan have been prepared, and the main actors have been identified. One of them was the Ministry of Defense and Department of Emergency Situations, which were responsible for collecting the pesticides and storage them in well-prepared warehouses. In February 2004, we ratified the Stockholm Convention, and since then it was a good start for us to work with the donors who helped us to identify funds for managing the problem. Also in 2004, we prepared and approved the National Strategy on Reduction and Elimination of POP Pesticides and the National Implementation Plan for the Stockholm Convention. The management and destruction of obsolete pesticides have been taken on a number of stages. I'll go one by one. The first one was the inventory. It was a very raw inventory. As Ella mentioned, we have 350 poor equipped warehouses. And at that time, we estimated to have 1,700 tons of pesticides, including 780 tons of unknown pesticides. The other big place where we had in the south of the country, it is a big landfill of 4,000 tons of chemicals. Out of them, 650 tons of DDT and 1.3 thousand tons of HCH. The second stage was repackaging and temporary storage of obsolete pesticides. In 2004-2008, the Ministry of Defense, with the Ministry of Department of Emergency Situation and with the support of Contact International, they collected all the pesticides from the country and stored them in 37 warehouses, very well equipped and guarded. And at that time, the quantity of pesticide was estimated at about 3.3 thousand tons of pesticides. To have a very well ground to avoid the accumulation of chemicals, such chemicals, and to improve the national legislation under the special project, I'll mention it later on. We made a number of legislative documents and bylaws which help us to improve the management of POP in the country. And starting with 2007, we tried to eliminate the obsolete pesticides using different funds, and this mainly have been done under the project finance from the World Bank, GF World Bank, Czech Republic support, National Ecological Fund or Environmental Fund, even from the national budget, which were of very great importance for us. Since 2007 till 2022, about 4.2 thousand tons of obsolete pesticides, including solid and liquids, have been eliminated and disposed of in France, Germany, and Poland. Yes, even in Tredia also. Now we have very small quantities still in Moldova. Some of them are in Transnistrian region. The last 60 tons was eliminated from Transnistria this last year in 2022. Hope the activity of the ministry and other related authorities will support us to not have any more such accumulated chemicals. These are the most important project financed in our country, which helped us to eliminate the stockpiles of obsolete pesticides, the GF World Bank, as I mentioned, the NATO project, we had one, the OSCE project, which helped us a lot, and one project was implemented by FAO. Another activity related to inventory and mapping of POPs pesticides polluted area. As you can see, according to this inventory, we prepared a database which included all the sites existing in Moldova which are polluted with POPs pesticides. This database brings all the information required to the national authorities to take the decision in managing these sites. And there are about 1,600 hotspots, which were divided according to the hazard they present. Okay, I just have some. I will not stay on this table, it's too much information, but there are a lot of, there is a feasibility study and special reports which can be accessed, and we can find information there. Another activities done was based on the inventory done, we made some remediation activities. And these activities have been selected based on the costs and the ability of local authorities to apply them on their sites. 3 of them, these remediation techniques are coffer damming, we isolate the contaminated pesticides in coffer dams. We used at that time considered one of appropriate biological remediation with Darament and phytoremediation, which gave some results which at that time we considered can be applied in other sites. A lot of awareness activities and educational activities have been done. As mentioned in Bangladesh, we also managed to find some cases when people used old barrels or barrels from pesticides in their households. It was not very proper for them to do this, and we did a very wide communication or awareness and education campaign to learn them to not to do this, and to teach how to protect themselves from the sites which are contaminated with pesticides. I will not go in details about the conclusion, but as we know, the most important is that for a country to start working on pesticide is to have authorities accept that POPs pesticides is really a problem for the country, and to start working on them, to have a good cooperation among the main authorities involved in pesticides management, and a reliable cooperation with the donors is also very important to have it since the beginning of the activities. This will help them to find funds to implement the activity, the collection and the disposal of pesticides. This was very shortly about the activities done in mainly 16 years, but thank you.
Thank you very much.
Thank you very much, and it's maybe less a question but more a comment to encourage you to continue to look into how we remediate contaminated soil, because the big problem is you're an agriculture country, you need clean soil, but you don't have a lot of money. You cannot excavate it and bring it somewhere to a landfill, so you have to find cost-effective technologies and approaches, and especially you need to have a strategy and understand what is the role of each element. We have the same problem in the Central Asia project, and we're also looking at both bioremediation and phytoremediation combined. The bioremediation to bring us from several hundred ppm to a few dozen ppm, and then hang on phytoremediation from a few dozen ppm down to human health levels. So that's the approach we are trying to see whether that would work in Central Asia. But at the end of the day, you need a management process. Where is the waste? You have it already with your inventory, which is great. And I will come to you afterwards to know a little bit more details about this. But obviously from the knowledge where it is to how we deal with it, budget, experts, time, what is the remediation aim, goal, kindergarten, parking lot, industrial use, and so on. These are obviously a lot of questions which your government needs obviously to manage in a systematic way. Thank you.
Thank you. I definitely agree with you, but we hope we have now new people involved in the system, which are working in this area. Unfortunately, we're working now not in the ministry. The team which have been working for many years is already involved in other activities, but still we're communicating with the people from the Ministry of Environment, which can do a lot for this. We hope they will take proper decision and action to solve this problem in the next future.
On top of that, I could tell you that we have already tried one pilot project using bioremediation of POPs contaminated site from where the pesticides have been repacked and disposed, and afterwards also the warehouse was destroyed and separated per stones and taken by the people who are living around, and we have tried the bioremediation. Of course, it takes time and resources, and you have said we need to have a proper management who will take care, because the inventory is one, but afterwards, the budget should be included in the environmental agenda. Otherwise, the inventory is just a report. That's it. But you are fully right.
Especially, I don't think it's, there's no silver bullet. Tina Tin, who is sitting here, she will tomorrow present her bioremediation tests. She has managed to dispose 99% of the 18 different POPs in 6 months, so which is impressive, but this is only part. Besides the POPs, we have often heavy metals, which is an inhibitor and a toxic by itself. We also need to look into what are the products of transformation, not that we transform one toxic to another toxic. So at the end of the day, it's also not simple. And it's not only about time, but also understanding what you do and whether what works in Kyrgyzstan works in Moldova. That's also a totally different question. But I think it's important because we will never be able to incinerate such volumes of soil. We need to have economic and rather straightforward techniques to deal with that. Otherwise, we will continue to produce contaminated food.
Yes, thank you, Stefan. So if there is no any other questions, we may proceed with the next presentation. The same coming from Moldova, Valentin Plesca, manager of POPs unit in Moldova, who coordinated all of those activities which were mentioned previously by Larisa. 1 second, I'm trying to open.
So, good afternoon. My presentation will follow the presentation made by Larisa, and the origin of the problem of the described in my presentations are the same, but it is linked to the one big landfill of obsolete pesticides existing in Moldova. It is situated in the south of the country, near the border with the Ukraine, and not so far from the Danube Delta. 7 kilometers from the nearest village of Chishmikyoy. And this landfill was built in between 1975 and 1977 and put into operation in 1978. In this, the interior area of this landfill is 2.3 hectares, and included 14 waste storage pits. From first of 3 of them are concrete pits, and another 11 ground pits. The landfill is protected by the fence with a height of 2.5 meters, and is guarded by the state enterprise guard services. The current owner of the landfill is the National Agency for Food Security. This is the scheme of the landfill. The first 3 pits from the left are the concrete pits, and the rest 11 the ground pits. This is a picture from satellite before the beginning of the works in 2014, and the general description of the site include the size of the concrete pits are 30, 10, and 4 meters, and the size of the ground pits are various. The total volume of the pits is estimated about 26,000 cubic meters, and according to the available documents, the quantity of stored pesticides in this landfill are 4,000 tons, but taking in consideration the total volume of the pits at the beginning of these works were estimated that the total quantity is of the 16 tons of waste. In the period of 1999 and 2014, the situation at the landfill was monitored by the different specialized institutes from Moldova, and the situation in 2014, before the beginning of such activities of remediation of this landfill, was uncertainties regarding the amount of pesticides. We didn't know what is the exact amount of this waste. Insufficient knowledge of the degree and type of soil contamination and groundwater, degradation of the protective upper layer and of the storage waste, and degradation of landfill infrastructure, and growing concerns of residents from this area regarding the landfill negative landfill impact on environment and human health. The necessary measures considered to be taken regarding this landfill was this site investigation and feasibility study to determine more precise the quantities of and the kind of waste stored, and the most appropriate methods of remediation, estimation the cost of these works, and technical and equipment needs. After that follows the practical remedial works at the landfill. These activities were initiated within one project financed by the Czech Development Agency. Works were carried out by the Czech company DeConta and coordinated by our team within the Ministry of Environment. At the first stages and at the last stage, coordinated by the National Agency for Food Safety. The works were implemented in the period 2016-2018. The project had several components, several stages. The first was the site investigations, followed by the risk assessment, analysis of mitigation measures and recommendations, feasibility study, and practical rehabilitation works on the site. At the first stage, at site investigation, the objective of this work was to determine the amount of the waste stored, the nature of storage substances, and the degree of contamination, including geophysical investigations. These are the standard steps of investigation of sites in this case. As the conclusions after the site investigations, we have the following. The material within the landfill is contaminated or contain heavy metals, pesticides, different kind of pesticides, including organochloride pesticides, oil products, and other chemicals. In the most of pits, the contaminated depth interval is up to 5-7 meters below the tops of mounds. The top strata of the mounds shows relatively low level of contamination. The estimated amount of contaminated soil and waste and soil is approximately 37,600 cubic meter. Very limited contamination, contaminant migration from the waste deposits, and no contamination in the building structure, bottom sediment, and surface water. After the site investigation. The next activity was the risk assessment based on the results of the first stage. The main objective of this risk assessment was to assess significant human health and environmental risks related to the soil and groundwater impact, and determine appropriate mitigation measures. As the summary of total risk was determined that the soil contamination beyond the waste mounds had dominantly the point character, and it is almost exclusively related to the topsoil. The extent of soil impact indicates an inability of contaminants to migrate through the unsaturated zone to groundwater. No groundwater contaminations were detected, and unacceptable risks were identified for on-site workers and off-site farmers for any quantified exposure scenario. And in the last conclusion, the landfill in Chishmikyoy was considered as a potential serious contamination source, which requires the permanent control. Okay. Recommendations of mitigation measures were developed and used for the implement any remedial actions. It was considered that the option 2, upgrade the landfill containment, was the most appropriate for the conditions of Moldova, and from the feasibility study, 4 remediation alternatives were considered to be appropriate, but only the one alternative one, including capping of hazardous landfill, were considered appropriate for implementing in this case because of the economical consideration and from the technical considerations and the time for implementing. This is the cross-section of the proposed method of remediation of landfill of Chishmikyoy. And in conclusion, the landfill was restored in situ and integrated into the landscape. The rehabilitation was designed and executed in accordance with the Moldovan legislation and took into account the results of investigation and the monitoring of ground and surface waters. Thanks to the results of these works, a significant improvement in the safety of stockpiled pesticides and other chemicals has been achieved. And the main goal of the rehabilitation, which was to conserve the landfill and limit its impact on the environment, has been achieved. So, thank you, and sorry for the very
the next speaker is Ms. Lud. Yes, and the presentation is about pesticides, information source and waste management survey results from Azerbaijan compared to Georgia.
Welcome. I would like to speak about a project we did 2017 to 2019 in Georgia and Azerbaijan. And there in 2 surveys, we looked at pesticide information sources. So how do farmers learn about risks and hazards of the pesticides they use? And also about their waste management practices. So what do farmers do with pesticides when they don't want to use them anymore? So, and in the investigation, we found basically that the survey results reflect developments in waste management regulations in both countries. So in the presentation, I would like to present results of 2 surveys. One survey held in Azerbaijan and the other one in Georgia. And then I will briefly reflect on the situation regarding waste management regulations in both countries. And at the end, I will try to draw some conclusions from that. What we did was we conducted a paper-based survey on regional knowledge about pesticide and waste management. And we did that in Tamarisi in the Marneuli region in Georgia, near a former pesticide store, which we can see here on the photograph. And that survey had about 100 participants. And then we conducted the same survey also near a former pesticide distribution center in Ganja in Azerbaijan. And this survey was conducted together with an NGO, and they had 30 participants. The survey had several parts, and the work reported here is about knowledge about pesticides used and the waste management practices. A third part was about soil remediation. When we asked people about which pesticides they use, luckily no farmer reported any Stockholm Convention POPs, so all of the pesticide names or product names reported were non-Stockholm Convention pesticides. Many of them were copper-containing products, like for instance Bordeaux, and in Azerbaijan, sulfonylurea pesticides were mentioned most frequently. In Azerbaijan, also some organophosphorus pesticides were mentioned, whereas in Georgia we had, next to the copper-containing pesticides, mostly pyrethroids pesticides mentioned. We also asked participants to mention product names and active ingredients. And even though people were able to actually mention quite a lot of product names or quite a lot of active ingredient names, there were very, very few matches. So we had clearly less than 10% correct matches between active ingredient and product name, which already indicates that people lack knowledge about the pesticides used. Then we also had a look at how long people actually use the pesticides. And in generally, we can see that in both countries, pesticides are used well beyond the shelf life of the pesticides. Reports from Azerbaijan regarding the waste management showed that people report they use the pesticides basically until they're used up. So maybe also because there are no proper disposal options, they simply don't throw them away, but they use it as long as they have them. And in Georgia, some people reported that they use them even longer than 20 years, which is considerable. Yeah, and this also means that at the time of the survey, it could well have been that the pesticides used were from a time when the Stockholm Convention was not ratified. Yeah. Regarding the sources of information in both countries, we actually find that people need a friendly face. If they want information about the pesticides they use, they usually ask a person. So they ask friends and family or the retailer. So in Georgia, for instance, the retailer was the most important source, and there the practice simply is people bring their own container from home, and it could be a container, for instance, for detergents or any other container you have in your households, and then they go to a retailer and ask the retailer to fill their container with pesticides. And that means that any meaningful information, which is, for instance, on the label, is lost, especially if the pesticides are then used for a long time. And in Azerbaijan, also friends and family were important, but in Azerbaijan, for instance, also extension services were mentioned as source of information. But basically it's a people-based information system because the label is often lacking. Reported disposal options, they reflect the current waste regulation situation in both countries very much. So here we see an impression of the storage of pesticides. People store their pesticides out of the reach of children. So they hang the pesticides in, for instance, plastic bags up the ceiling. And the containers in which the pesticides are usually alternative containers. And when we look at the reported waste management options, most people state that if they dispose of the pesticides, dispose of them via domestic waste. And as I mentioned, in Azerbaijan, people say they use them for a long time, so they keep it for the next season instead of throwing the pesticides away. In Georgia, also burning pesticides was reported as a disposal option, and some people also reported that they dispose of the pesticides via special hazardous waste. However, in the rural situation in Georgia, actually this is not possible, because there is no separate special hazardous waste collection, or at least there wasn't at the time. So basically this reflects the insecurity also of people how to deal with the waste, because there is no proper waste management implemented in the rural areas. So looking at the current waste regulation situation, so since the ratification of the Stockholm Convention, both countries have made some progress regarding legislation. So for instance, a publication from scientists from Georgia and Austria reports that the domestic waste stream is not separated in Georgia. What they did is they took samples of domestic waste and then looked at the composition. And I got in contact with them and asked, well, what would have happened if an alternative container with hazardous waste like pesticide waste is disposed? Would you have detected it? And they said, no, it would probably not have been possible to detect this because they investigated what was in the waste bins, but did not do detailed chemical analysis. So the reported amount of hazardous waste in the paper probably underestimates the real hazardous waste in case of repackaging. Then CASA and co-authors, for instance, they report waste collection rates for rural Georgia, which vary from 25 to 95%, with an average of 64. So that means in the countryside, in both countries, waste management needs more efforts. So basically, from the surveys we conducted, we can conclude that further efforts are needed in waste management. but also in awareness about how to deal with hazardous waste, and especially also in the implementation. So people really need sufficient, adequate possibilities to deal with hazardous waste. In the survey, we also looked at educational level of the participants, and we found a positive influence of education on safe handling and disposal. So it makes sense to raise awareness, it makes sense to educate people, and so it means that also further efforts for better training in all forms, so whether it's vocational training or academic training or informal training in the context of lifelong learning, all of this is beneficial to protect environmental resources and to make sure that agricultural products are safe and healthy for everyone. Thank you very much for your attention. And yeah, if there are further questions, the floor is open.
Hi, thanks Daniela for the great presentation. I have a short question about, you mentioned the farmers are asking extension service for advice about the use of the pesticides. But if they need advice about the waste management, to whom they're going to ask? Do you know that extension service is also providing advice to the farmers about the waste management, or the farmers just do the waste management by themselves or by their knowledge?
Let's say based on what we saw in the countries, the farmers do it themselves. Yeah, the extension services that was mentioned in the small subsample from Ganja, where an NGO, which is active also informing farmers about biological farming alternatives, where they have been working with the farmers, so probably there were also more personal relationships, and then people tended to ask the NGO as well, probably. Yeah, so I would guess that's, let's say, the fruit of the active work in the area around Ganja. Mm-hmm.
I might add to the answer. Here sits my colleague from the Azerbaijani Food Safety Agency, who are exactly responsible for such questions. They are actually just starting to establish a collection system, and we see it working. We are currently safeguarding obsolete pesticides in Zheng landfill, and sort of every 2 months we see a lorry coming with another collected amount of plastic bottles with expired but also not expired pesticides. So it's a starting collection system. I think it takes time till it's countrywide and comprehensive, but at least something is starting. Our estimate, based on what we have seen, is that Azerbaijan has about 20 tons of unused pesticides at the end of the agricultural season. I think this is not a hard number, but gives at least a dimension of at what amount we look and where we should also try to optimize the management so that we have less volumes purchased at the beginning and unused at the end of the season.
Yeah, thank you. I think that's an important remark. And yeah, probably one of the points is that, let's say, for instance, in Georgia, a lot of the farms where we worked with people, they were quite small, so 1 hectare, and then the pesticide amount they need per year might be quite low, and that might be part of the issue. Yeah. Mm-hmm.
Okay, that was the last presentation for this afternoon, but we have some time for discussion. What I can suggest is if anybody has any follow-up questions relating to any of the presentations, you have a chance now to ask them. But also if anybody has an intervention, any comments that they would like to make that are relevant to the subject that we've heard about this afternoon, then I'm quite happy to open the floor to those as well. So if you have a question or you'd like to make an intervention, please let me know.
Sorry, it seems I'm always taking the microphone. Well, we have heard of all the high temperature incinerators. Unfortunately, they only exist in sort of industrialized country, and I would not consider China as a development country, as was stated by our Chinese colleague in his presentation. I really can see in the countries where we work that there is really a need for a high temperature incinerator, not only for POPs pesticides, but I think in general co-processing can do a lot, but it cannot substitute a high temperature incinerator. On the other hand side, a high temperature incinerator costs 200 million initial investment. So you need obviously to have a mature waste market who gives you the 100,000 tons a year. I understand this is a big hurdle, but I still would sort of, try to motivate our colleagues from Tredi, Veolia, and other companies maybe to see whether they could engage with these governments and develop a business plan which would then maybe in one of these countries in the region see a high temperature incinerator appear, because it has its unique role. There are some things only HTI can do. Thank you.
Thank you, Steffen. I mean, given your final comment, I think it's only fair that I give the opportunity to one of the representatives, maybe from Tredi or Veolia, to respond and maybe explain what would present an attractive commercial opportunity to spend or invest 200 million euros in a new facility in a new market. Grégoire, Montse, do you have, Grégoire has his hand.
Thank you for this relevant question. So, our strategy is currently to go to underdeveloped countries and developing countries, and we are trying to develop like on-site solutions. It could be hard, as you said, because it's very high investment, and we have to deal with like the geopolitics and like local problems, and we have to find out a partner on site, and this is not that easy. But from our side, we are trying to develop and to move forward in that way. This is the goal.
Thank you, Grégoire.
Yeah, we heard China talking very much about co-processing of POPs and pesticides. And I just wanted to mention that on Thursday morning, there will be a session in room 2, if I'm not mistaken, where cement co-processing and what can it do and what can it not do will be discussed. So for those who are interested to know more about the co-processing, they could join that workshop if they have time.
Thank you, Ed. I'm happy to see that the room is at least as full as when we started. So clearly there is an interest in technologies for treatment. So there's another opportunity there on Thursday to hear about some other approaches. Anything else?
I mean, I think the points that are coming up now are really important in relation to the presentations we've heard. We've heard about, I worked for many years on the issue of identifying stockpiles of obsolete pesticides and finding solutions to remove them and move on from there. The problem with that approach is, there are multiple problems with that approach. We are dealing with a single issue. The stockpiles of pesticides normally belong to the agricultural authorities. That's where they came from. The agricultural authorities don't necessarily talk well with the environment authorities in many countries. So there isn't a good dialogue there between those that are responsible for looking after the environment and dealing with waste and those that have generated this particular waste, which has generated a particular solution. You don't see the same approach so much in other sectors, with the exception of, again, very selective solutions that deal, for example, with PCBs, because they're POPs and they're covered by the Stockholm Convention, and there is funding that will help to bring about solutions. So I really think it's important to be looking at this in terms of more holistic, integrated solutions for hazardous waste management. Because frankly, I've been working in this area for around 30 years, and I don't think we're that much closer to solving the problems. So unless we start integrating this with the bigger management of hazardous waste on a national level on an ongoing basis. So not just the legacy stockpiles, but what's being generated every day, every month, every year, from hospitals, from industry, from transport, from all of the sectors. If we don't put in place holistic solutions into which the legacy stockpiles can also be fed, we're not going to solve this problem. It's too big to be able to do it on a piecemeal basis of taking out selectively bits of the waste and transporting it halfway around the world to be dealt with somewhere else.
Yeah, I couldn't agree more what you just said. I'm sorry, I don't know your name yet, but we'll find out later. Actually, even when it comes to local solutions as co-processing, if co-processing in a country is not existing for whatever reason, then even the cement kiln is not going to be the solution for some of the POPs, because the cement kiln will never invest the amount of money only to solve 2,000, 3,000, 5,000 tons of POPs pesticides. So even all my reports so far have always said this kiln can do it. It's technically impossible, it's financially feasible, but only if it is part of your waste management infrastructure in this country. And by using co-processing, you have the chance to upgrade your waste management infrastructure in a relatively cost-effective way. So I agree completely with your thing, and I would like to point that out, that is really something in which direction part of the solution also lies.
Thank you, Ed. Yeah, I mean, I think, to be honest, what Mark said, what Ed has said, what Steffen is asking somehow is linked together in my mind, is that building an expensive hazardous waste treatment plant is not the first step to solving the problem. And I strangely, considering my job and my career, I agree with what Mark says, in that by picking up 100 tons here, 100 tons there, and treating it, we don't move forward. But to try to answer your question, Steffen, to make an investment as a shareholder-owned company, we have to be certain that the environment we're working in, meaning the country we're working in, is stable politically, has the regulation and enforcement that's needed to support our investment and the solutions that we're bringing, whether that's high temperature incineration, whether that's co-disposal, whether that's thermal desorption, or any of the other technologies we can talk about, is, for me at least, irrelevant to that discussion. We have to create a mature regulatory environment where industry in that country is engaged in the environmentally sound treatment of its waste that it's generating from its profitable ongoing activities. And then we start to solve the problem. But I think it's difficult to see us making that move quickly in some of the countries where we see the biggest problems. So we will have to be imaginative as well.
Thank you. I have a general question about coordination and cooperation between the countries and sharing of positive experience. At the moment, if I live in Kyrgyzstan, if I want to know what to do with the DDT and other pesticides, where he should go and to check? Is there any platform where countries can share their experience, so the other countries will access and say, okay, the Kazakhstan, Bangladesh, Moldova, they have positive cases, how they resolve, so I can follow their cases. So is there any platform, maybe already exists, but I don't know about that, where the countries can share their positive experience? Today, I found out about Georgia, Azerbaijan, about Moldova efforts, and I didn't know that yesterday. So maybe it will help to the countries. As I said, in Bangladesh, we are making the documentary film about the DDT disposal that FAO can share with other countries, but maybe existing on the platform that all other countries, maybe within the EU or Central Asia, they can have access. Okay, this country did this one, we can follow their case instead to go to think how to do it and how to manage. So this kind of coordination, cooperation, it's kind of very also important, and sharing of positive or negative experience, it will help countries definitely.
Yes, you are right. And to confirm you personally, I don't know such kind of platform where all experience all around the world is placed, but at least the platform which had been used by us, by Moldovan, was the platform of a forum. And starting from 2003, actually, we have tried to participate all the time. And we have, at that time, we have realized, and also we learned from the experience from other countries. For instance, in the project which were mentioned by Larisa, we have had a component dealing with PCBs. And at that time, participating in the forums which were organized, we have now found the expertise which were available at that time in Switzerland, also the experience from Macedonia, from Romania, and only, in a direct communication with the partners from those countries, we have succeeded to implement the activities which were planned. And at least, as John is saying, it's not necessary to invent the wheel. The wheel is already known. It's just a method to take the experience from those countries and to implement. I've seen the project which was implemented in Bangladesh, and the same components were in Moldova back in 2005, which was one of the first GF projects after the China one. So you see, the experience had been taken from that project in 10 years, even more 10 years later and you have succeeded. Also, you said that 6 months from the first notification in March was launched, and in October you got acceptance for transborder movement. I could tell you that in 2006, in more than 8 months, we were fighting to get notification to export in France. So from March to October is less than 6 months. So you have succeeded. But again, 10 years ago, that was a difficult problem to get the acceptance. So step by step, learning from other countries, we may improve. Of course, we may come with, with suggestion to the COP in order to construct such kind of platform where the experience are shared. In Moldova, we have had our own webpage, moldovapops.md, where the entire information starting from the NIP development until the last project with disposal of obsolete pesticides have been placed, including all handbooks and awareness materials have been placed over there. So as John said, the publication and leaflet with the impact of POPs pesticides have been translated in different languages. The same has been done in Moldova. So it's a matter of stakeholders from the country if they would like to promote the activities. If it is abandoned or it is taken only for 1 year, so for sure you'll not get any success.
Saso, I think there are 2 types of plastic in agriculture. There is plastic for pesticides containers, and there's all the rest. If it comes to pesticides container, the issue there, it's obviously has been in contact with a toxic product. So depending on legislation, it can be considered as hazardous waste, or after triple rinsing, as many tests have proven, not being hazardous waste. But this is obviously a country situation. But FAO, CropLife International, the big international industry, they are working on collection schemes and disposal schemes for empty pesticides containers. And I think there are about 50 countries globally which have empty pesticides container management schemes. So there's still another 100 and so to go. With regard to agricultural plastic waste, this is rather a new subject. We have in Rome at headquarters, I think for the last 2 years, a working group, and they published, I think about a short year ago, a first report trying to understand how much agricultural plastic waste is generated every year, and even there the problem starts that they are not really statistics. So there's a weak understanding what is the size of the problem and what could be done about it. But I think the problem with agricultural plastic waste is that it's often very dirty, and I don't think it's me personally, without being too involved in that work, I don't think that it can really be recycled for non-alimentary purposes, but probably the question is how could it be recuperated in a way that you can in a meaningful way then incinerate it and recuperate at least the energy in it. But it's ongoing work, and maybe FAO has more answers to that in 2 or 3 years from now.
Thanks, Steffen. I think there was one hand here at the front as well.
Yeah, about the plastics project. There is a project in Thailand, Vietnam, Cambodia, and India, where they are putting together all the efforts to see how they can manage the plastic litter in the waters, but also from agricultural use, etc., etc. And I don't have the name by heart, but I can always share with people if they are interested.
Thank you, Ed. That's very helpful. So maybe is there a last question?
Can consider it a bit of a curiosity of mine. There was this permeating theme of public health affected by the stockpiles, by the improper storage. And I was wondering, because I haven't really seen anywhere the Ministry of Health anywhere. Probably in Bangladesh they don't need one more node in the letter. But is there an interest from the public health sector in maybe helping with information campaigns because I mean everyone has a medic a doctor in their villages. So I was wondering if anyone has experience with working with those from the public sector, and if these ministries are even interested in looking into POPs and HCH and everything.
I'm not sure if I got the whole of the question and what was being asked. It's about linking up with the Ministry of Health. Okay, so the project that I'm currently working with, which I will talk about a little bit tomorrow, but I'm very happy to have the opportunity to talk about it a bit more in a moment here. Project I'm working with the University of Edinburgh is called the Centre for Pesticide Suicide Prevention, because 20% of all suicides globally are carried out by intentional consumption of pesticides. And there's a problem which is well recognized in ministries of health, because they see people arriving in hospital dying from their exposure to pesticides, and it's not occupational exposure, and they don't know what to do about it. So this project has been working for a number of years, putting the people from the Ministry of Health with their data in direct contact with the pesticide regulators, so that they understand what the real impact of their pesticides is on health. It's usually this acute exposure, but sometimes there are chronic exposures as well, and sometimes accidental exposures as well. And once the regulators see that and understand the scope of the problem, which is generally much, much bigger than they believe it is, they are usually ready to take action. So we've currently taken that project. We started in Sri Lanka a number of years ago, where regulatory action is estimated to have saved something close to 100,000 lives. And we have replicated that approach in Nepal, Taiwan, Malaysia, China to an extent, some places in India. It's a bit more difficult there. We are currently working with all of the East African regulators, the Southern African regulators, the Western African regulators, the Caribbean, and we are looking also to expand into other countries. And we are having great success informing the regulators, bringing the health authorities into that, and it brings about significant changes. So the answer to your question is yes, it can be done, and it needs to be done.
I think it's been a very interesting afternoon. Everyone stayed till the end, so I suggest you found it interesting also. For me, it reminds me that we have technologies that can deal with this waste, and those technologies have proven to be effective. We have technologies that have been around a long time, but we have new technologies emerging to deal with new challenges that the waste brings to us. So let's say from a technology point of view, I'm optimistic. We see with the projects that were shown this afternoon in Bangladesh and in Moldova, that with the right organization and energy and application, that we can bring those technologies to bear and have a positive outcome. But the comment was made, we're moving too slowly, and things don't really seem to have changed in the period of time I've been involved. And when I mean changed at a kind of global level. And that brings me back to the conclusion that if we have the technology, maybe what we need more of is the pressure from people, people that bring pressure to politicians, and politicians that have the ability then to influence the institutions and organizations that control the ability to move forward. We in this room are in a privileged position that most of us either work in or for, or have interaction with the government, with politicians, with institutions that can make a difference. So what I would ask you all to do is to go away and use whatever energy you can to try to make that move in the right direction, and to bring the influence you can to help us to move forward. And the only thing to add is to thank the presenters this afternoon, and to thank you for being here, and thank you for the comments and questions that you raised. I found it a very interesting session, so thank you very much.